Hello, I'm Florence Kailiwai-Barnett, Director for Center Operations and Support. I'd like to welcome you to part one of a panel discussion with members of our Center's senior management team. This discussion is a part of the Center's Shuttle Safety Communication Plan, which is designed to convey common agency themes and messages on shuttle safety. Furthermore, this discussion is used as a medium to communicate with our employees on key topics and issues which face us today. Our panelists today are, starting at my far left, Dave Geiger, Site Director, Rocketdyne; Lon Miller, Deputy Director, Propulsion Test; Boyce Mix, Director of Propulsion Test; Mark Craig, Deputy Center Director; and to my right, Roy Estes, Center Director; John Thomas, General Manager, Lockheed Martin; and Keith Humphreys, General Manager, Johnson Controls. We asked our employees, both civil service and contractor employees throughout the site, to generate questions for our panel. These questions will be presented by a representative group of employees seated in our audience. Before we get to our questions, I'd like to ask Roy to say a few words about the big picture as you see it.
Thank you, Florence. This is a new experience for me to communicate with you, our employees, and our colleagues, both in NASA and in our contractor workforce. And I'm sure there are others that work here at Stennis Space Center for other agencies that may see this also. This experience, we are trying to better communicate with all of us here at Stennis on where we're going and what our challenges are, what our opportunities are as we face the future. At this point, I would like to sort of step back from Stennis a little bit and take a look at NASA. Over the last several years, we've been about reinventing ourselves, restructuring the agency and downsizing, or right-sizing, whatever term you'd like to use. We've done very well at that. We collectively, you and we and others at other centers. As a result, we substantially have decreased the cost of doing certain elements of our business within NASA. As a result of that, our approval rating, as indicated by congressional votes, has increased substantially. Now our budgets and our programs are being passed on voice votes, where just 2 or 3 years ago it was very close votes. 2 years ago, we were looking at a ever decreasing budget down in the $11 billion kind of level. Now our budgets are stable at the mid-13s as far as we can see. Now that's the good news, and that is that we through hard work and our leadership of our folks in Washington have stopped that decline with the support of the President and with the Congress. Now the bad news is that we want to do many new exciting things. We want to prepare to go to Mars. We want to build new propulsion systems. We want to have new science programs. And in order to do that, we're going to have to generate that revenue within this flatline stream that we are now pleased to have. We do not see ever increasing double-digit increases budgets like we saw 7, 8 years ago. So the incentive for us to continue our diligence in controlling cost is there. And we are going to be talking more about that in other parts of this program. In the programs, NASA has chosen to consolidate its activities to be more efficient and ultimately to save cost, and we are benefiting from that. You'll hear more about that from Mark Craig. We're going to benefit from this current downsizing at our programs here. You'll hear more about that as we continue on in this program.
Great, thank you, Roy. And now, Mark, would you tell us a little bit about the NASA strategic plan and our part in it?
Sure, I'd be happy to, Florence. Picking up on what Roy talked about in terms of the big picture and what's happening, what is strategy? Where are we headed? Well, strategy is nothing but how it is we're going to get where we need to go, taking into account all these things in the external environment that Roy mentioned. Now, ultimately, strategy is only meaningful if it shapes budgets and if it shapes what people do, us, people that work in this in NASA. The NASA strategic plan, let me start there and then hopefully describe how it flows down to what we do here at Stennis. We're about to release the 4th edition of the NASA strategic plan. It takes time to learn how to do these things properly, and I think we're about there. It also has to change as the environment changes and we identify new things that need to be done. Fundamentally, what the NASA strategic plan does is identify the 4 lines of business of NASA: the human exploration and development of space, strategic enterprise; the mission to planet Earth, strategic enterprise; space science; and aeronautics and space transportation technology. Those are NASA's 4 lines of business. It also, at the very top level, defines what each center is responsible for and what each center does. It defines our role here at Stennis as being that in propulsion test and in commercial remote sensing. I hope as you get the chance you'll read the NASA strategic plan. It really does lay the framework for where the agency's going and lays the framework for the things that we need to be doing here at Stennis. That top level plan then flows down into strategic plans for each one of the strategic enterprises. And let me talk about the 2 that affect us most: human exploration and development of space and mission to planet Earth. The human exploration and development of space, or HEAD's strategic plan, came out in '96. It kind of lays out the playing field of where we're headed in the human exploration of space, but it doesn't have in it yet a real path. And that's what we're now beginning to focus on. We're focusing on what it's going to take ultimately to send human beings to Mars in the 2014-2018 kind of a time frame. I've been very honored personally. Mr. Trafton, the Associate Administrator for Spaceflight, has asked me to provide leadership as we lay out that strategic plan. So let me describe a little bit about what the strategy to get to Mars is and how all this ties together. As Roy mentioned earlier, we think realistically we can expect no new appropriations to undertake these kind of activities, sending humans to Mars. So our strategy, given that, has 3 basic tenets. The first is to open up a wedge. Look at the assets we have, the space shuttle, space station, and find a way to free resources within those programs. How do we do that? Well, first, the shuttle. We reduce the shuttle's cost. We've made tremendous strides in doing that already. We are looking at now an aggressive program of upgrades to the shuttle that will reduce its cost and make it more attractive eventually. The ultimate goal is commercialization of the shuttle. All of that activity, by the way, will involve to some degree, probably a greater degree, propulsion test. So that's how it will affect us. Increasing the flight rate is another way to reduce the cost of the shuttle. The more customers you have, the lower the cost per flight. Open the wedge. The second step in that then is, as we open the wedge, to look for other ways to get resource that don't come from the government to allow us to head to Mars. International partnerships, the things we're doing on Space Station, are a prime example of that. Looking for non-traditional sources of money in foundations, in selling the technology we develop, as an example, would be a way to get more resource that's not appropriated. So we've opened a wedge using shuttle and station. We've looked for other sources of revenue to make it happen. The third step then is to find better, faster, cheaper ways to send humans to Mars. That will involve a lot of things. It will involve some kind of a heavy lift vehicle, which we see as a derivative of some of the shuttle upgrades, like a liquid flyback booster. That also will involve more propulsion tests. The Mars Pathfinder, which is so successful as we're filming this session, will be one of the foundations early on that we'll be looking to undertake activities that help us develop the technology for sending humans to Mars. And now we're looking at sample return missions, bringing pieces of Mars back here to Earth in 2003 and 2005. Within that HEAD strategic plan, to kind of sum it up, the bottom line and really the springboard is the shuttle. That's the springboard that's going to get us to Mars, allow us to open up this wedge, and its safety. That's why it's so vital, and that's one of the key messages and themes that we want to make sure is discussed today. Let me talk very briefly then about the Mission to Planet Earth strategic plan. We're in the third version of that plan. It's just coming out as we speak. It establishes Stennis's roles as the lead center for commercial remote sensing and our role in Earth system science. It also recognizes, very importantly, for the first time, a goal of developing a robust commercial remote sensing industry in this country. Those then flow down into the Stennis implementation plan, our final step, and this is where it starts to get home and tell us what we need to do here. We've just begun work on that plan to respond to the HEAD strategic plan and the Mission to Planet Earth strategic plan. We hope to have that completed by the end of this year. It will identify our lines of business here at Stennis. It will lay out our basic strategy of having low-cost operations through our multi-agency environment. It will define how we're going to implement our lead center responsibilities, and ultimately then it will flow down into the performance plans of each one of us. So that's the basic flow down. NASA and its strategy at the top, the strategic enterprises and their strategy, our implementation plan here at Stennis. I really do hope you'll take the time to read these, see where the flow is, see where things are going, and as you do, think about how it affects your job. Vicki Zanoni, think about how it affects the partnerships you're working in commercial remote sensing. Harold Talby, think about what it means as you shepherd procurements through the system. Walt Parks, think about what you can do to contribute to the direction that's laid out as you look at maintenance scenarios for the center. Jim Anderson, as you're doing your earth science research. Freddie Douglas, as you're leading the examination of new test configurations. And me, as I'm thinking about PathWorks and the subjects we should be addressing there. Each of us needs to put these in perspective, understand how we can contribute in our job to this direction that's been laid out for the agency. Thanks, Florence.
Thank you very much, Mark. And now, let's begin the question and answer portion of our program.
Hello, I'm Rachel Raines. I work with Lockheed Martin as a senior software analyst. My question is, what will it mean for South Mississippi for Stennis to be named NASA's lead center for propulsion testing?
Maybe I'll take that first, and I'm sure others will want to add too. Well, first of all, it means quite a great deal. I'd like to just start with a little history. Werner von Braun conceived the idea for this center back in the early 60s as a national test center. And just about time we got going in Apollo, we ended Apollo. We started in Shuttle, and we did a lot of tests over the years, but we never really did name a lead center for rocket tests. We never did really designate this as our leading national center. That now has been done. The agency has decided to name us the lead center. What that means is that we direct and lead the rocket propulsion testing not only here, but also at the other 3 installations within NASA that do rocket propulsion testing. This is done to provide more efficiencies, more effectiveness in terms of the way we use our resources, and then along those lines, hopefully ultimately to save cost. What will it mean to Stennis? Well, it means that we are in the driver's seat, if you will. In the driver's seat means we have some responsibility to steer this vehicle in the right direction. We are investing in facilities here. As you know, we are completing some existing facilities that we had under construction. We plan modifications of other facilities. This all enables, in order to enable us to consolidate to the extent possible test activities here. And so what it means is, as opposed to 2 years ago when we were substantially going out of business after the completion of the shuttle main engine upgrades, that now we are going to be in the test business, and I expect some positive growth. So what it means is a continuation of the world's best test team, and hopefully some substantial growth and some growth in the test area.
And one other thing, as an engine contractor, it's kind of neat to have one-stop shopping. Instead of going to 4 different centers for my propulsion test needs, now I can come to one to coordinate all of my test activities.
Well, that's kind of a summary of what it means inside the center, but since we all live in this community, we are obviously interested in what happens when we're away from work. I'm sure you all know that Stennis infuses about $110 million a year into the communities within a 50-mile radius of this. And what this is going to mean is that number is going to get bigger. And when that number gets bigger, not only because of the funding, but because of the type of people that's involved in meeting this demand of the lead center, they're going to need to be more talented. I think that by virtue of more talented, you're going to be seeing a higher pay scale, and that within itself will upgrade the local talent within this area for not only Stennis but some of the other industries as well. And then you can parlay that one step further. if you've got the need for all of these resources, high talented resources within the community, then that means that the school has got to get better and get more challenging curricula in order to bring the folks here that's gonna fill these positions. So it benefits us inside and outside the center to a tremendous degree.
That's exactly right, John. As a matter of fact, this has to come to the community leaders as really great news. As you know, there's a group of people outside the gate called the Partners for Stennis that have been working with us here on the center to try to secure our position in the NASA mission. And it looks like that's happened. And that means that, that the position of this center and the business here are secure for the foreseeable future. And of course, the growth, as you mentioned, John, is certainly going to be welcome because as Mark mentioned a few minutes ago about flow down, whatever comes into the Stennis Space Center flows down to the surrounding communities.
I'm Michael Jensen. I'm an engineer for NASA, and I'd like to know what propulsion test projects other than SSME testing are planned for Stennis.
Currently, we have SSME testing on 3 test stands at Stennis. We plan to take one of those stands out of service at the end of August and start conversion for the X-33, which is a prototype of the RLV, which is expected to fly in '99. That program has a duration of about 1 year on the A1 test stand. In addition, currently on the B2 test stand, we have low-cost boost and horizontal fast track. Those are propulsion test initiatives from the Marshall Space Flight Center that we're doing here that are low-cost 60K LOX-RP engines, and those I think will probably have a long duration. They'll continually upgrade those programs for a number of years as new technologies evolve. In the E-complex that we're currently are completing, we are spending $45 million to finish that facility. Currently on the books we have RLV components, we have advanced space transportation system components. Rocketdyne Commercial has book space in there. Air Force integrated test propulsion has got space bulked in there, and I think it's going to be a continually growing area for us as we develop those facilities and demonstrate our capabilities.
I'm Willie Ellis, component technician for Johnson Control. My question is, how is NASA actively pursuing new test programs at the Stennis Space Center?
Willie, maybe I'll take that one on to start with. Any way we can. We have just about everybody that we have any influence with working with us. First of all, but let me say that we have an organized, a well-organized effort within NASA. We have a specific focal point, a new program office whose responsibility it is to be on the road, if you will, making sure that the Stennis Space Center capabilities are well known by those developers around the country that want to build new hardware. So we attend the right meetings, go to the right conferences, and we send out the right data packages, and we read the right information to make sure that we are continuously aware of what development is going on in the country. And as a part of that outreach program now, I'm happy to say that the word is out that Stennis is the focal point for testing within NASA. And now industry is beginning to come to see us and ask about our capabilities and what our plans are, what our costs are, what our commitments can be. Then additionally are the contractors, one of whom you represent, here on the center are major national entities. And they help us in getting the word out and what's going on here at Stennis. And then, of course, the political leadership, both state and federal, help put the word out. Now, last but not least, I want to say that the most emphasis and the most leadership has come from our NASA headquarters. First naming us the lead center, and then directing that this system be put in place, and that those who wish to do rocket testing first within NASA, and then some help from them with the DoD. So that has been a tremendous help and has been the guiding light for us.
If I could add to that just a little bit, Roy, Another area that business comes from is follow-on business. The work we do here is top quality work. As we do that kind of work, our customers tend to come back again. We have a lot of repeat business right now, and everything we've done so far has brought business back from the same customers, and that's what underpins the capability, as Roy was saying, to go out and market this place aggressively. As long as we do the good job here, marketing is not an easy job, but it's a job that can be very well done.
Well, you see, I got a little bit more of a pragmatic view of that. Even though we're helping Alon in this marketing business, I got to believe that if this lead center thing works, and I have no reason to believe it won't, just the opposite, I think it has to, and if NASA stays in business in the manned space flight arena, which there's all indications that it will, then the work is coming to Stennis. It's just a matter of fact. Since the lead center has been declared as Stennis, and there's going to be propulsion systems required to get to Mars, and there are even propulsion systems now talked about for a flyback booster, that has to come here. So it's a pragmatic arrangement. If NASA stays in business and we stay the lead center, we got the business.
You know, to sort of, if I can go back to that subject, sort of put a ribbon around that, the real popular thing now in Washington, popular in the sense that more people recognize this, the access to space for a pound of payload into Earth orbit, whatever altitude, is being put there by technologies that are 25 and 30 years old. And it has now become popular to understand that the future of the development space, the commercial development space, is going to be controlled by those who can get to space the cheapest. And so while a pound out of orbit is roughly $10,000 in cost, if you can get to $5,000, $3,000 a pound or lower, then you're going to have the business. The Japanese, the Chinese, the Russians, the Europeans are all aggressively competing against us for that business. This is a business proposition. So American industry and the federal government knows that we've got to make these investments, and those investments are going to flow down to Stennis as we do our job in propulsion tests.
My name is Anthony Jackson. I'm an engineer for Johnson Controls World Services. My question is, being the lead test center, does this mean that all test programs will be relocated to Stennis Space Center?
The quick answer to that is no, but to elaborate a little bit, the American taxpayer, all of us, has invested literally billions of dollars in rocket test facilities across the country, both NASA and the Department of Defense. It doesn't make much sense to start taking wrecking balls and bulldozers to multi-billion-dollar facilities and tearing them down and moving them somewhere else or rebuilding them somewhere else. The time to recover that kind of an investment is tremendous. It'd be too long of a time to recover. So what we're doing is we're slimming down a little bit. We're repackaging things. We're basically setting up two primary NASA test sites for most of the test work that'll be done. Stennis for ambient low altitude type testing with a similar to SSME, and then White Sands Test Facility under Johnson Space Center out in New Mexico for the high altitude space environment type of stuff. So distinctly different kinds of testing activities. Then we have Marshall Space Flight Center and Lewis that are research and development centers that will maintain a certain level of test capability to support their research activities. So what NASA ends up with is basically two sites for two different types of test jobs and then two research sites.
My name is Doug All. I'm a remote sensing scientist with Lockheed Martin. My question is, what role will Stennis play in becoming the Mission to Planet Earth lead center for commercial remote sensing?
Doug, Mission to Planet Earth at the very highest level has two goals that are right up our alley here at Stennis. The first is to develop new ways of business that make it cheaper for Mission to Planet Earth to obtain scientific data, and also that extend the benefits of Mission to Planet Earth to the broader population. The second one is to promote U.S. industrial leadership in commercial remote sensing. Those things are the things we do here at Stennis. They have been and will continue to be the core and the essence of what we do as the new lead center for commercial remote sensing and mission to planet Earth. So what does that involve? Well, it involves what we've been doing in our programs like EOCAP, finding pathfinders for new ways to do this, to reduce barriers, to create new partnerships. It involves determining the intersection between commercial requirements and science requirements, together with Goddard and headquarters. It means in the future, and I think this is a real opportunity for us, really being the agent that can help verify and validate commercial remote sensing data for the government and for industry. And that's an area that we're going to be looking into quite a bit in the future. It also means we'll be doing things like initiating data buys. This $50 million data buy that we are just now in the process of developing, of actually, rather than the government building spacecraft to obtain scientific data, buying that data from the commercial industry. So all of those things that we're doing now are the platform for what we'll do as a lead center for commercial remote sensing.
Well, this mission to planet Earth is a real important thing. And you can hear various discussions of that at the national level or anywhere that there's an intellectual forum happening. Vice President Gore is very much behind Mission to Planet Earth. But what is that? Mission to Planet Earth is a program that is looking to determine the interaction of our planet and its environment and how that affects life on this planet. Also, how our behavior is affecting that delicate balance. And to do that, you need a whole bunch of information, and Mark has described how that can happen, either build satellites and get it or buy the data from some commercial entity. Well, I gotta believe that this program is critical to this species survival on this planet, and that's the understanding that's going to come from this program. And how we'll react in that in a much lesser way in this purchase of the data, this $50 million, which is a pretty good chunk of money in anybody's book, is Stennis is going to be the broker for that, and we helping Stennis is going to be the broker for that purchase of data, and that's going to come from commercial entities, and I think we'll see a great advantage of that, and maybe more of it in the future. So it's a great thing, and we've got to support that.
My name is Mark Eister. I'm a systems engineer for Rocketdyne. And my question is how does a company gain access to SSC facilities? And does the project have to be rocket propulsion?
That's a two-part question, so let me answer both of them. First of all, I'd like to think that every employee that works on this site, whether they're a contractor or government, will encourage whoever you interface with in your workday, whether it's a customer or a professional in another professional organization, to encourage those people to consider Stennis as a place to do business, especially if they're in the rocket propulsion activity. That's kind of at the grassroots level. Now we do have the formal entry points. Our new business development office in the propulsion side, under Patrick Sherman, handles new business coming in, has all the procedures, the paper and so forth that needs to be processed, and which ultimately leads to Space Act agreements or whatever other legal vehicle we choose to document the arrangement and do the work under. And then you asked, do they have to be rocket propulsion? And that in itself really is a two-part question too. The first answer is our lead center of excellence, our strength is rocket propulsion testing. So we would expect to see most of our customers in that business in one fashion or another. We wouldn't encourage a customer to come and have a new vehicle designed here. That's a Marshall Space Flight Center job. but we have successfully located and helped companies outside of rocket propulsion tests through our technology transfer activities, and of course in our remote sensing activities as well. We have an aggressive program in technology transfer to bring companies in, utilize NASA develop technology, and then go make money and go make some money in the private sector with that technology. We have an incubator program where a company can locate in a closet-sized office for a while and then graduate to a larger workspace, and ultimately hopefully graduate to out into the mainstream world and go make it happen.
My name's Nate Ficken. I'm with Lockheed Martin and electronic tech in the PT&O section. My question is, because Stennis has been named the lead center by NASA in the propulsion testing and the commercial remote sensing, how does that benefit Stennis and NASA as a whole?
Nate, I'd like to take first shot at that question. First of all, I'd like to preface my answer by saying I haven't been as excited about what's going on at Stennis since I was a younger engineer in the Apollo days. And let me say the following. All during Apollo and the early part of Shuttle, we were basically a support organization to rocket testing. Just 3 or 4 years ago, the Rocketdyne test contract was transferred here. We were given the responsibility for that. Now with this new strategic plan that Mark talked about earlier, we have been named lead center. Lead center not only for rocket testing, but also for remote sensing, that we have already adequately covered. What this means, this gives us a place at the program table at NASA. Now this is a change for us. This is a cultural change. We no longer are supporting. We have a responsibility. We have a responsibility not to support, but to lead. And when you say rocket testing in NASA, we are to lead that area. That is a substantial responsibility. And so we've got to step up to that. And I think we're doing that very well, particularly in the propulsion area. We're working on our facilities. We've got to work on our business systems. And so we have to work on every aspect. We've got to work on our thought processes, on how we approach that. And so what it means is a whole new era of responsibility for the Stennis Space Center. And we are in the beginning days of that. And so as I see the future, it's exciting as we develop those capabilities and that responsibility.
Ultimately, if you look at from a NASA perspective, the real benefit of having lead center is that there's now focused responsibility and accountability. It's not distributed. It's one person, one organization, which is a real platform and opportunity for excellence. And that's how we need to look at it. As with Roy, though, I think we need to keep our eyes here on the challenge too. We no longer now just open the gates. We are responsible for rocket propulsion test wherever it occurs within NASA. That's a big responsibility. We're going from an environment now where we've had one customer, SSME, to having multiple customers at multiple sites. That takes a whole different mindset, a whole different set of processes. Rather than being buried in tech transfer, commercial remote sensing now has a huge responsibility and is kind of the vanguard for the new way of doing business and mission to planet Earth. That is a huge responsibility. So with all these opportunities and benefits, which are substantial, come real challenges, which I think we ought to look forward to as a team tackling, getting on top of, and demonstrating that it was for good reason that these responsibilities were given to us here at Stennis.
The lead center concept is also very similar to what's happening throughout industry today. Industries we're finding are beginning to focus on their core competencies and to outsource everything that they believe is not within their core competency. So that's essentially what NASA has done here, is they've decided that Stennis and the other centers have certain things that they do very well, and that you need to consolidate those at a single location where you can do very high quality and cost-effective work. Part of what you achieve out of this is an economy of scale, because you get better utilization of the assets and facilities, and you don't have to replicate that cost at various other locations. So that's good for NASA because ultimately it's going to save money, among other things, and it's good for Stennis because it secures the mission here at Stennis into the future.
Yeah, well, if given a choice, I'd rather have the aspect of being at Stennis than being somewhere else in NASA at this time, because because the effect is almost contradictory. It's kind of like opposite. At Stennis, being lead center means you get more money, you get more responsibility, you get more authority, and you get more accountability that goes along with that. But with that, you get more people, and everything generally is in a brighter frame of mind. But the way this thing works, and the reason it's a benefit, is that the rest of NASA as a whole in propulsion testing has to decrease. The infrastructure has to go away if you're going to save any money as a result of this lead center approach, and that's the idea of the whole thing. So we can then take that saved funding that comes from those other decreases and apply it to, as Mark said earlier, apply it to these new programs like Mars and so forth. So selfishly, I'd rather be here. Fortunately, I am.
That's right, John. That's how we open up the wedge. That's the name of the game.
Well, one of the other things, just to pick up on where Keith was headed, if you look at propulsion test as a process, and to pick up earlier on Roy's comment that the key to space is the cost of access to space, and propulsion test is one of those big contributors to reducing cost or increasing cost. You've got to work on that process to make it better, quicker, cheaper. And one of the neat things, I think, and one of the exciting things that Lon's folks are involved in is working with the other centers that are in propulsion test and sharing ideas and picking up best practices. We think we do things great here, but I bet there's some neat things and better things out of White Sands or other locations that we can pick up on and do better here. And so that's a big benefit.
Go ahead, Speaker. I thought you ought to tell our colleagues about the Rocket Test Management Board and how that works.
I will do that. Yes, this was a good comment, Dave, that you made. This is a very exciting time for Stennis and for a lot of us. Personally, I've been fortunate enough to be deeply involved in lead center formation and working with our other three sites, Marshall, Lewis, and White Sands, and forming a team made up of representatives from each of those sites. And just as Dave alluded to, we have specifically taken other procedures and approaches to problems and ways to do business from the other sites and adapted those for use here, as they have done with procedures that we use here for use there. We all gathered around the table about 2 years ago, and we knew we could probably all benefit from sharing that way. I think all of us might have been a little skeptical because we felt we did it better than anybody else, and what possibly could they tell us that we don't already know or already do the best in the world. But like it or not, we did find out that they did things better than we do in certain areas, and we do better than they do in certain areas. So right now, we're using a White Sands checklist for definition of project requirements. They had that down very well. When they went to talk to a customer, they went through a checklist and just checked off the requirements. Nice, neat, easy way to do it. And so we've had a lot of sharing like that, and to try to kind of tie all this together, then we struggled with how do you lead a lead center? How do you make this happen? NASA hadn't done it yet. We find ourselves out there on the end of this limb, and a lot of people in NASA are cheering us on, saying, go do it, but waiting to see how we did it. So we, early on, it's been about a year now. Last August, we formed what we call the Rocket Propulsion Test Management Board, which is the body that we use to essentially govern the lead center activities. It's made up of representatives from all 4 sites, and it's chaired by Stennis. And we make the decisions on where test investments are made, where test programs are assigned. And the specific stated role of this board is to get maximum utilization of NASA's test facilities, and with minimum investment in new facilities and maximum use of resources. So it's a very challenging thing to do, but with a year under our belts now, I think we've come a long way since a year ago, and we have some things to be very proud of, but we have been supported to a great deal by the other centers as well. So I think NASA as a whole, with the 4 propulsion and test centers, can be proud of what we've done.
And you've got a documented track record of cost savings for this first year. What is that?
Yes, we have, and I thank you for reminding me. In the board, we can show specific and traceable cost savings of $13.5 million over the last 11 months, essentially, of operating.
My name is Bill Hughes. I'm an instrumentation engineer with Rocketdyne. My question is, how long does Stennis plan on testing the SSME?
Well, currently, NASA plans to fly shuttles well into the 21st century, and whether that's 2012 or 2030, Stennis's role in that activity is we support the Cape for anomaly resolution that may occur during a flight, that we would have the ability here to test an engine to try to duplicate the condition that they may see. There are critical components on the SSME that requires ground testing prior to putting in the flight program. And again, as engines wear out at the Cape, new engines will be brought through here for acceptance tests. So I think as long as shuttle flies with SSMEs, Stennis will have a role in SSME testing.
Yeah, now the role in the out years, if everything just stays flat and nothing changes, obviously is going to decline. Right now, there's no long-term upgrades planned. There's a lot of talk about it, shuttle upgrades, and there are some plans on the books, but nothing listed out and funded yet. But they're kind of exciting. Some neat things like liquid flyback booster and also shuttle upgrades to meet the future. But once those things become more solidified and funding's allocated towards that, I think you'll see much more testing for SSME in the next century, or some version of SSME.
My name is Bo Clark. I'm an engineer in the Construction Management Division for NASA. My question is, are any future programs being considered for testing at SSC besides the X-33 and the R-68, and what effect will that have on employment levels?
Quite a few new programs, Bo, lined up here at Stennis. Things such as liquid flyback booster, low-cost boost, X-34, fast-track engine development, and a number of component programs and developmental programs that are helping various developers perfect their hardware. As far as the employment here, we do see an increase in employment due to these, but we also have some employment decreases coming down as SSME completes certification programs on the various blocks that they're working on. And as programs naturally come and go, we'll see varying levels of employment for a particular program. But our challenge is to try to level that off, add a slight increase to keep our workforce involved and busy at work testing rockets here. And so I think over the next few years, we're not going to see employment going off the charts at a steep rate, but we should see a nice, healthy, steady growth rate up to some level where we're essentially at full capacity here.
One of the neat things, if you look at just this last few weeks with Mars Pathfinder, the interest in space has just gone astronomical. And I don't know if it's just the climate of where we are today and with respect to the world and everything, but the interest in space is just growing dramatically. And if you look at what's out there just around the corner in this next century, space exploration has tremendous potential out there and tremendous benefit to all of us. And I just can't believe that we're just going to be filled up with stuff to do to go explore.
And Dave, also, as we all know, starts with propulsive devices, leaving the Earth. So it's however it plays out, we should have a sound role in it.
Yeah, I think if you look at the nation, I mean, this is interesting. I mean, the interest in space has just grown astronomically just in this last year.
Let me offer a contractor perspective on the employment part of the question. I think, as everybody knows, we've seen fairly significant growth in the population out here and on all of the prime contracts and also within NASA itself. One of the things we have to keep in mind is what comprises that growth. And all of the growth and then some has come from the new programs that have come here to Stennis Space Center. In fact, the workforce size that was needed to support what I'll call the baseline work has declined over the last few years, which is an indication that we're all learning how to do things better and more cost effectively. And that's very significant, I believe. What that says is that the people at Stennis Space Center have learned how to do things in a way that's going to bring business here, because industry and government programs are going to look at Stennis Space Center and say this is a good place to do business. And that's going to support that additional personnel, if you will, that's on top of the baseline. So while the baseline workforce has declined, overall we have grown, and that is because of the new programs, which I believe will be sustained because this is a great place to do business.
I'm Donna Dukeson. I'm a mechanical technician with Rocketdyne, and my question is, are there any plans in work to expand the test facilities?
Expand the test facilities. The role that we need to do here is, we've been sort of single engine, single program for a lot of years, and I think what we need to be able to do in the future is run multiple propulsion systems across our various test stands. So we'll be working on concepts to make that possible. We don't have the capability currently on the site to do LOX-RP full engine systems that would be required for liquid flyback boosters. So we'll be in the next year putting that capability in, whether it be on V2 or where we elect to do that. As Z1 matures and we get testing going on there, it may be that the test activity increases to such a rate that we'll have to build additional cells onto that facility to accommodate that. So I think we have a good future with expanding facilities in that role.
Nate Ficken with Lockheed Martin, Electronic Tech in the PTO section. My question is, what are the chances that the ASRM facilities will be utilized in any major new projects in the near future? And if so, what type of projects might they be?
As the prior ASRM project manager here, I'd like to be able to offer a bonus to anybody who brings in a major new project for that site. But the fact is there aren't too many 3.5 million pound thrust solid rocket motors out there needing to be tested. The only one flying in the world is being happily tested in northern Utah. So what we're doing, we are using that site right now for some small hybrid testing. It's serving a very useful function to get that program up and running. As soon as we finish our E-complex work, that program will migrate over to the E-complex. The benefit to the H1 site is it's remote. It's away from the main test site. It's got a dock. It's got roads. It's got utilities, water, power, sewer. Everything's out there really ready for something to come in there. We're actively marketing that. We're actively trying to find somebody to come in there. That could be some kind of a propulsion, possibly big hybrid motors could be tested out there with the addition of lock systems and so forth. Assembly operations. Right now it's a nice site that could be fit or molded to a lot of different activities. So we hope in the next few years to have somebody out there doing something.
Well, I'm not sure I won't ever hear the term ASRM again, but that's beside the point. There is a small test program going on out there now, and that's the hybrid program, a hybrid solids, and Lockheed Martin is deeply involved in the development of that evolving technology, which I think it's coming. There's a test now, I think it's being tested at Marshall, a 250K test thing, and depending on the outcome of that, it's my understanding that if that comes out very positive, then they're going to go to a larger engine, and I believe that plays right into our hand here, because the larger the engine, the more limited places you can test our motor, the more limited places you have to test it. So that puts us in good stead with having the H1 out there to do it.
My name's Mark Iser, and I'm a systems engineer for Rocketdyne. Y'all have touched on flyback boosters. I was wondering, will the flyback boosters be tested at SSC, and will we need new facilities to test it?
Well, that decision will have to be made by Lon's Rocket Propulsion Test Board based on the availability of facilities and what the current programs are. But right now, the engine systems that we know about that are potential candidates. Again, like I said earlier, we're our LOX RP, and there's the F1 that flew Apollo that's a candidate, the Russian RD-180 engine, and we understand Rocketdyne is proposing a new LOX RP engine that's called the RS-76. New facilities, again, would be adaptation of the current facilities we have with LOX hydrogen capability to accommodate single engine. If there was a requirement to test a full-scale booster, again, looking at the configuration of it, if it could fit into a facility, then B2 currently is probably one of the largest facilities NASA has in the country. So if there was a need for a system level test, then B2 would be probably the place where it would be tested.
Thank you. Bo Clark with NASA Construction Management Division. The question is, what new testing capabilities will the E-complex provide, Stennis?
The E-complex made up of E1, E2, and the E2, E3 area, when done in the next couple of years, it will provide a capability that doesn't exist anywhere in the country, possibly in the world, from very small materials development type testing, blades, so forth, cold flow facilities up to large combustion devices, turbopumps, capability in the area of 5,000 gallons of liquid hydrogen at nearly 8,000 pounds per square inch gives tremendous duration capability and pressure and flow capability that just doesn't exist right now. We'll have pretty much a spectrum from, in other words, from little to giant pieces of hardware that E-complex can handle, and with shared facilities, shared data systems, shared fuel and oxidizer systems, it should also be the most efficient facility in the country to do that kind of testing.
Bo, I kind of believe that that E1, the E facility in total, particularly E1, is of paramount importance to our test roll down here, because if you look around the U.S. and around the world, you can find large propulsion systems in numbers that you can count on one hand. RLV, or the X-33, and its successor, the couple of EELV engines, and so your likelihood of getting many big test programs down here is not in the future just because they're not there. But having the component test facility, there are hundreds of potential programs available to you if you have the facility of the class that this one is going to be out there. You're going to be able to test anything from turbo pumps to small hot fire thrusters. So that is a very good complement to the capability that you have on large test stands.
Bo, I'd like to add a personal and an agency perspective to what we're doing in the E-complex. We're investing a lot of money to start with. Why are we doing it? First of all, we've been challenged, as Lon has said, to have the best facility in the country and the world to do that. Why? Not just so we can have a facility. The intent is so that we can have high quality testing. That's essentially a rocket engine that we're building out there in the form of a facility where we can insert rocket components and develop them. And we want to be able to have high throughput through that facility. A lot of devices, good quality data, lowest cost per unit test time, device in cost, so that again we can work this low cost access problem to orbit. We can have a test facility that provides that capability, and we can do it at an economical and reasonable price and get the job done. And so NASA's investing substantial money. Now, for a little bit of perspective, I'm going to feel a whole lot better when we pressurize that facility and it works. Now, I'm assured by all the engineering community who's reviewed it time and time again, but I want to see it pressurized and see it work. And then we can breathe easy and begin to activate it, put devices in it, and check it out.
Hi, I'm Trish Penn. I work for NASA in the Earth System Science Office. And since I've been at Stennis, we've only had the one main test program. Now that we have these multiple test programs coming online, I'd like to know how you guys think it's going to affect our subcontractors.
Oh, well, Rocketdyne doesn't have any subcontractors, but let me just to give you kind of a lead in, and then the folks at Duke can kind of deal with that. But the neat thing about this is that when you step back and look at it, the access for test facilities is premium time, and so if we ever work together as a team before we got to now, because we're going to have all kinds of different types of engines and components that we'll be testing, and so communication is key to that. The biggest cause for most of the problems we have is failures in types of communication. And so we're all moving forward to make this vision happen, and so we've got to have very open, clear communication systems, and it's got to flow down to our subcontractors too. And I'll let some of the folks that have subcontractors.
Well, we do, and some darn good ones at that. We have Cimarron and GB Tech and DataStar, and we also have Botel, who does a lot of the communications work. And I don't foresee any change in their perspective or their roles or their assignments at all as a function of this lead center role, except in a positive way, because as we grow, they grow, because they're doing very important parts of this program with GB Tech up at the labs, and Cimarron in the computer operations, and DataStar supporting commercial remote sensing. So it's a good deal for them.
We also have subcontractors, and I believe as well that it's going to have a positive impact on those subcontractors, not just the new programs that are coming here, but the new way of thinking about how we do business. As I mentioned before about focusing on core competencies, we like the rest of the folks out here have trimmed ourselves down to the point where we don't have as much depth on the bench, so to speak, like we had years ago. So we are using a higher reliance on subcontractors to come in and take care of surge work. Not only that, there are certain things that we do that are done infrequently, so it's difficult to maintain your level of proficiency when you don't do it very often, and the need for recurrent training is high when you try to self-perform those tasks. So those are areas also that we are looking towards subcontractors to augment what we do here.
Shamber, a budget analyst for Johnson Controls World Services. What is the longevity of some of the new engine testing programs, such as the Aerospike and the Phantom Booster?
Well, the Aerospike is a reasonably short program. It's limited to a couple of turbopump assemblies. It's got several engines that will go through development, certification, and finally a couple of flight engines, and potentially maybe a full-scale engine, because the engines we'll be testing on the A1 test stand are essentially a half an engine that's going to be on the X-33 vehicle. So there is some chance, if they have enough money, to do a full engine system. So that whole program is, from the time of start of test, is about 1 year. Bantam Booster, on the other hand, is a low-cost Marshall project. It's a lot of the component. In fact, they've just sent out requirements to people to bid on turbopumps and chambers and parts of the engine, and they're like ablative nozzles, and they're turbopumps with very few moving parts. So I would think that program has the chance of going on a long time. I think that as people develop cheaper and cheaper components to go into the low-cost booster system, that'll continue to develop, and we'll probably have a program in for many years.
I'm Donna Dukeson, mechanical technician with Rocketdyne, and my question is, although the B-2 test stand has been slated for NASA's low-cost boost technology program for next year, what are the future plans for the B-2 test stand?
The immediate plans we have for B-2 is trying to get LOX RP capability here, so we can do low-cost booster engine, whatever engine system they decide to want to run development testing on. Follow-on testing would be either the liquid flyback booster system, any booster system that the nation would need for future use would be tested on B2. It currently has the capability of 10 million pounds thrust, which is probably makes it and B1 the two unique facilities in the world for that capability.
Yeah, I'd like to underscore what Boyce has said, Donna. I'm glad you asked about B2. You know, for smaller test facilities like the E-complex, and even for a 1 million pound capability like the A test stands, there are several of those around. When you get into the 10 million pound class, these are truly national, international assets. And so as the country deals with access to space and something emerges, either an RLV or EELV, flyback booster, or other new engine systems that will emerge as we go into the next century. It's my view, and I think a certainty, that that test stand will be pressed into service for the systems test, the all-up systems test. We've done that for Saturn, and we've done that for Shuttle, and it'll be done for the next major booster also.
The next question is, if XRS 2200 prototype engine is successful, what is the time frame for testing of the full-size linear aerospike engine?
Currently, the X-33 engine finishes up its test activity in late '99, and then it has the flight demonstration. If the RLV vehicle is selected as the choice by Lockheed Martin, the first flight engine, or first full-scale RLV engines we get in here are in the 2002 timeframe.
I think we can all agree on the panel that these were very thought-provoking questions that were presented to us, and we do thank the audience for your participation. Before we end the program, however, I'd like to turn this over to Roy and have him say a few closing remarks.
Thank you, Florence. I would start by adding also my thanks to those around the center that helped craft these questions, and to those of you who came today and participated in voicing them. Your participation and those questions will cause us as managers to go back and think about these questions, and hopefully push us even further. And also thanks to the rest of the panel members here for participating and for their thoughtful answers to these questions. I'd like to conclude by reminding you of why we're doing this. First of all, is to communicate with all of our colleagues and co-workers here at the center on where we think we're going and where we are what the opportunities and challenges are for the future. But I want to end by emphasizing a couple of points. One is personal safety. I've had the unpleasant experience over the years to be advised of injuries to individuals and even deaths to very few, but one is too many. And I sure don't want to be a part of any of those experiences anymore. So it's a responsibility of me, it's a responsibility of you for our own individual and personal safety. It's also the responsibility of me, and it's the responsibility of you to look out for our co-workers. And if you have an engineering or quality or safety or managerial or any job, let's look out for each other in terms of our personal safety. And then our principal job is to fly the space shuttle safety. Principal and number one priority of the agency. We have people here who put their hands on flight hardware and who can make the difference in whether or not it performs in flight right. We have engineers who make decisions regarding that. We have people who provide parts. We have people who look at data. A variety of people here that work on the program that ultimately can determine whether or not we have a safe day at the launch pad. We want to ensure that we do our part so that we will continue to have safe shuttle launches as we've had in the past. Thank you for your diligence in the past. That safety record that we have here at Stennis is clear. We want to continue that as we go forward in the future. Thank you for listening today.
Ultimately, to send human beings to Mars in the 2014-2018 kind of a time frame. I've been very honored personally. Mr. Trafton, the Associate Administrator for Spaceflight, has asked me to provide leadership as we lay out that strategic plan. So let me describe a little bit about what the strategy to get to Mars is and how all this ties together. As Roy mentioned earlier, we think realistically we can expect no new appropriations to undertake these kind of activities, sending humans to Mars. So our strategy, given that, has three basic tenets. The first is to open up a wedge. Look at the assets we have, the space shuttle, space station, and find a way to free resources within those programs. How do we do that? Well, first, the shuttle. We reduce the shuttle's cost. We've made tremendous strides in doing that already. We are looking at now an aggressive program of upgrades to the shuttle that will reduce its cost and make it more attractive eventually. The ultimate goal is commercialization of the shuttle. All of that activity, by the way, will involve to some degree, probably a greater degree, propulsion test. So that's how it will affect us. Increasing the flight rate is another way to reduce the cost of the shuttle. The more customers you have, the lower the cost per flight. Open the wedge. The second step in that then is, as we open the wedge, to look for other ways to get resource that don't come from the government to allow us to head to Mars. International partnerships, the things we're doing on Space Station, are a prime example of that. Looking for non-traditional.
Hello, I'm Florence Kailiwai-Barnett, Director for Center Operations and Support. I'd like to welcome you to part one of a panel discussion with members of our Center's senior management team. This discussion is a part of the Center's Shuttle Safety Communication Plan, which is designed to convey common agency themes and messages on shuttle safety. Furthermore, this discussion is used as a medium to communicate with our employees on key topics and issues which face us today. Our panelists today are, starting at my far left, Dave Geiger, Site Director, Rocketdyne; Lon Miller, Deputy Director, Propulsion Test; Boyce Mix, Director of Propulsion Test; Mark Craig, Deputy Center Director; and to my right, Roy Estes, Center Director; John Thomas, General Manager, Lockheed Martin; and Keith Humphreys, General Manager, Johnson Controls. We asked our employees, both civil service and contractor employees throughout the site, to generate questions for our panel. These questions will be presented by a representative group of employees seated in our audience. Before we get to our questions, I'd like to ask Roy to say a few words about the big picture as you see it.
Thank you, Florence. This is a new experience for me to communicate with you, our employees, and our colleagues, both in NASA and in our contractor workforce. And I'm sure there are others that work here at Stennis Space Center for other agencies that may see this also. This experience, we are trying to better communicate with all of us here at Stennis on where we're going and what our challenges are, what our opportunities are as we face the future. At this point, I would like to sort of step back from Stennis a little bit and take a look at NASA. Over the last several years, we've been about reinventing ourselves, restructuring the agency and downsizing, or right-sizing, whatever term you'd like to use. We've done very well at that. We collectively, you and we and others at other centers. As a result, we substantially have decreased the cost of doing certain elements of our business within NASA. As a result of that, our approval rating, as indicated by congressional votes, has increased substantially. Now our budgets and our programs are being passed on voice votes, where just 2 or 3 years ago it was very close votes. 2 years ago, we were looking at a ever decreasing budget down in the $11 billion kind of level. Now our budgets are stable at the mid-13s as far as we can see. Now that's the good news, and that is that we through hard work and our leadership of our folks in Washington have stopped that decline with the support of the President and with the Congress. Now the bad news is that we want to do many new exciting things. We want to prepare to go to Mars. We want to build new propulsion systems. We want to have new science programs. And in order to do that, we're going to have to generate that revenue within this flatline stream that we are now pleased to have. We do not see ever increasing double-digit increases budgets like we saw 7-8 years ago. So the incentive for us to continue our diligence in controlling cost is there, and we are going to be talking more about that in other parts of this program. In the programs, NASA has chosen to consolidate its activities to be more efficient and ultimately to save cost, and we are benefiting from that. You'll hear more about that from Mark Craig. We're going to benefit from this current downsizing at our programs here. You'll hear more about that as we continue on in this program.
Great, thank you, Roy. And now, Mark, would you tell us a little bit about the NASA strategic plan and our part in it?
Sure, I'd be happy to, Florence. Picking up on what Roy talked about in terms of the big picture and what's happening, what is strategy? Where are we headed? Well, strategy is nothing but how it is we're going to get where we need to go, taking into account all these things in the external environment that Roy mentioned. Ultimately, strategy is only meaningful if it shapes budgets and if it shapes what people do, us, people that work in this in NASA. The NASA strategic plan, let me start there and then hopefully describe how it flows down to what we do here at Stennis. We're about to release the 4th edition of the NASA strategic plan. It takes time to learn how to do these things properly, and I think we're about there. It also has to change as the environment changes and we identify new things that need to be done. Fundamentally, what the NASA strategic plan does is identify the 4 lines of business of NASA: the human exploration and development of space, strategic enterprise; the mission to planet Earth, strategic enterprise; space science; and aeronautics and space transportation technology. Those are NASA's 4 lines of business. It also, at the very top level, defines what each center is responsible for and what each center does. It defines our role here at Stennis as being that in propulsion test and in commercial remote sensing. I hope as you get the chance you'll read the NASA strategic plan. It really does lay the framework for where the agency's going and lays the framework for the things that we need to be doing here at Stennis. That top level plan then flows down into strategic plans for each one of the strategic enterprises. And let me talk about the 2 that affect us most: human exploration and development of space and mission to planet Earth. The human exploration and development of space, or HEAD's strategic plan, came out in '96. It kind of lays out the playing field of where we're headed in the human exploration of space, but it doesn't have in it yet a real path. And that's what we're now beginning to focus on. We're focusing on what it's going to take